All right, everyone, welcome back for the next topic, recorded in my very own bedroom. I was gonna go record these in the office, but as I look outside, it's the middle of May and it's snowing, so didn't want to deal with that, and we'll be recording them here. But anyways, moving on to the biopsychological approaches to motivation. I think that this topic is generally a bit less conceptually difficult than the last. But yeah, really broadly, we'll be going over um, aspects of this, such as endocrine systems and how that kind of interacts with nervous systems and various hormones, as well as brain structures. And so, as with the last section, this will be split into three different videos. The first will be all about stress response. Oh, and I want to mention that the first activity is associated with this lecture. And so all three of these biopsychological videos. And so as you're watching this first video, you should be able to go through and answer the first couple aspects of that activity or worksheet. The goal is to just have you kind of write down and go through some of the key parts of these lectures. That's the whole point of these activities. Is I know that online asynchronous can be difficult, so these activities will hopefully help keep everyone on the same page here with the important aspects from the lectures. And so, yeah, that'll be due at the end of this week. And at the end of this week, after the due date, I'll post a key for that and everything so that you can see how I would have gone through and I responded to those questions. But yeah, just meant to be not an assignment with not very much pressure, just supposed to be a learning tool. So yeah, the first part, gonna just go over this. I mean, if you've had a specific, biopsychological type of class or whatever, I'm sure you've gone into these types of things in much more depth than we'll be going into today. But I just want to broadly go over some general important biopsychological aspects. So the first is the autonomic nervous system. As you see, I'll move, makes it tough to see there. I'll move this to the bottom. So yeah, when talking about nervous systems, we're talking about the signals from the brain to spinal cord and then various organs. With the autonomic nervous system, there are two main different systems or divisions to this. The first is the sympathetic, which at the broadest level, that's on the right here, is associated with the activation of arousal. And so therefore, this leads to fight or flight responses, versus the parasympathetic division as more of an inhibition of arousal. So with this parasympathetic system or division, you'll be in more of a relaxed state, or the goal of this system is to get you into more of a relaxed state. Another very important part of this process are the adrenal glands. And so these sit right atop of those kidneys, and I've heard them be referred to as looking like fortune cookies. So I don't know if that'll help you remember these, but yeah, they consist of two parts. So you have the medulla, that's the inside part, and you have the cortex, that's the outside part. And so distinction is going to be important when we start talking about the hormones that are released by the adrenal glands, as the cortex and the medulla release different hormones. And so the adrenal glands are involved in the stress response because they receive signals from various locations that we'll talk about. And then based on these signals, they release various hormones. And this can certainly be adaptive when needed for things like responses to danger, but we'll talk about how this is not necessarily always the case, and it kind of depends on the system that is giving these adrenal glands a signal. Um, so the first system that let me make sure I covered everything. Oh, sorry, my computer's been so weird with the animations, but anyways, I won't have us watch that right now, but if you're interested, this is definitely a useful video that kind of just goes into the bodily stress response in general. It's pretty quick, I think it's like 4.5 minutes, so I definitely recommend that you watch that. But anyways, first system that I want to talk about here is the sympathetic adrenomedullary system. It's kind of a mouthful, so we're going to talk about that as the SAM, or the sympathetic adrenomedullary. And so basically, the key part to remember about the SAM is that it's a it's a very quick stress response system. And so that's typically what you see when we're talking about the nervous system, which you can get from the sympathetic aspect of this, is that's going to be a quick response. And so what happens is that there is the sympathetic activation, and then that sends signals to the medulla, medullae, since there's technically two of those. So again, that's the inner portion of the adrenal glands, which will then release the neurotransmitters of epinephrine or adrenaline and norepinephrine or noradrenaline. And this leads to behaviors associated with the fight or flight response. So this occurs in scenarios such as being startled. So I think the most commonly used example and the easiest to just think about here is, let's say you're on a hike and you turn around and you see a bear, and you get startled, and you have to decide how you're going to react to that. And you have to decide quickly how you're going to react to that. That's going to be the SAM system at play. The second system to talk about here involves the hypothalamus and the pituitary gland. And so, yeah, the hypothalamus sends signals to that pituitary gland, which then releases hormones of its own into the bloodstream. And so the hypothalamus is just right here, right above that pituitary gland, which releases hormones important to stress response. This is going to be called the HPA axis. And so that written out as the hypothalamic pituitary adrenal axis. And so this, as opposed to the neurotransmitters, or sorry, not neurotransmitters yet, the hormones talked about in the last slide, this will be involved in cortisol release. And so we see with the HPA axis, we have the hypothalamus that then gives signals to the pituitary gland, specifically the anterior pituitary, which then leads to ACTH release through the bloodstream, signaling to the adrenal cortex that cortisol should be released. And so this is more of a long-term response, and that typically systems that are working through the bloodstream are going to be more of long-term responses, as opposed to the systems using the nervous system as a way of signaling. That's going to be a lot quicker than the bloodstream. And so this, again, is also critical in reaction to stress, but again, it's going to be more of a long-term response, and it's going to take longer for all this to happen versus the SAM. So just quickly to compare these two systems that we've talked about here, the SAM system is going to be associated with more of a short-term response, fight or flight. The hormones here are adrenaline and noradrenaline. Those are released, and so We also see an increased heart rate, as well as an increased cardiac output. We also see decreased total peripheral resistance, or TPR. The broadest way to just talk about this or know this, I don't need you to know the TPR in depth, but basically when there's a decrease in total peripheral resistance, that just means that blood vessels are opening up and allowing for more blood flow. Versus the HPA, again, that's more of a long-term response. This is involved in a cortisol release. Again, with that being a long-term response, levels of cortisol often reach their peak about 15 minutes later. And then, as with the SAM, there's an increased heart rate. However, with this system, you don't see the increased cardiac output. And instead of a decrease in TPR, there's an increase in TPR. So those blood vessels are going to constrict and make it more difficult for blood flow. And so you can see how we're going to talk about health later on. And so you can kind of hypothesize just from seeing this, how the HPA system with the increased heart rate, but the not seeing an increase in cardiac output as well as increased TPR, can kind of hypothesize how that might lead to those long-term health effects that are associated with long-term stress reactions. So you might be wondering, what do these systems have to do with psychology? Well, we see that which system is used, or which system dominates, oftentimes both of these systems can be going on at the same time, but which system dominates depends on how we perceive the stressor. And so if we perceive the stressor as more of a challenge, this is kind of can be thought of as more of a thought process where you think, oh, I can handle this, and the resources outweigh the demands of the task, whatever that task is. Here, we'll see that SAM system at play, so that kind of more short-term stress response and the decreased TPR. And so stress is typically more adaptive here, versus if we perceive that stressor as a threat, and this is more of a thought process of like, oh, this is dangerous to me or threatening to me, I can't handle this, and the demands outweigh the resources. And so here, oftentimes the HPA will dominate. And so there's the increased TPR, and stress is often maladaptive here. So just a quick example, taking a test can be thought of as either a challenge or a threat, and that is going to change the, again, biopsychological systems at play, and it's going to, in general, just change how you would go about tackling that test, how you would handle that stressor. And so we'll talk about this more when we get to things like learning, where how we perceive a stressor or something that's difficult can really have a large effect on how we behave in terms of tackling that stressor or whatever it is, and can also lead to performance differences, as we'll talk about here. So I want to just provide a couple quick examples. So social evaluation scenarios are common for being perceived as stressful. So they're stressors, and they're also often associated with more of a threat perception as opposed to that challenge perception. And so this, in psychological experiments, is just a classic way of inducing stress. So if you're trying to measure certain responses to stress, how people behave after stress, this is a very common paradigm, is to just have people, or at least tell people, that they're going to have to go give a speech, and then you see that stress response increase. And so in this study, participants were instructed that they're going to be giving a speech, and then they were asked to write about their feelings regarding the speech before giving it. But the twist here is that they were told to write about their feelings either in a first or a third person perspective. So that third person perspective, I mean, first person perspective is just, I guess, kind of how you normally perceive it, but third person is, in other words, that's self-distancing. There's a few terms for that in psychology. It can also be called reappraisal, reappraising that situation. But basically, it just involves kind of taking a step back and distancing yourself from that scenario, as though you are kind of a third person looking in. And so what we see here is that when you look at these charts, the first person perspective, when writing feelings about the speech from this perspective, this was associated with more of a threat response, versus the third person was associated with more of a challenge response or perception of this speech. And then we also see that with that first person perception, there was an increase in the TPR versus less of an increase with the third person perspective. And then again, as we talked about a couple slides ago, as expected, with these different perceptions and systems that seem to be at play here, there's less of a cardiac output with that first person perception and more of a cardiac output with the non first person perception. And so, yeah, just an example of how perceptions of this task, and whether you're looking at that from a first or third person perspective, can then influence whether you perceive this task to be a threat or a challenge, which then is going to influence which endocrine system is used. One more example here, kind of in a relatively similar study here, but then this also includes a measure of performance. So baseball players were instructed to give a speech about sports, and interestingly, as we see in the right part of this chart here, those who perceived that speech as more of a challenge then also were seen to, in general, perform better offensively or in batting scenarios throughout the season than those who perceive the speech as more of a threat. And the idea here is that the stress response, again, that's associated with the challenge, is more adaptive here with performance. And so hypothesizing that those who perceived the speech as more of a challenge also perceived batting as more of a challenge as opposed to a threat, and therefore with that more adaptive stress response, they did better, versus with the HPA, which is that long-term stress response, and cortisol levels aren't even spiking for another 15 minutes well after the batting attempt. So yeah, that's should be it. Yep, that's it for this video. Be back here to talk about in the next video. We'll be talking about some of the other hormones.